Hey everybody, Dr. A here, and in this video we are continuing with our introduction to statics, and we're going to go into a few simple examples. Again, most of these examples are more along the lines of Physics 1, but we want to make sure we are comfortable with the vocabulary and the concepts. So let's go ahead and jump right into it. So example 1 says that we are given a mass that is 3.72 slugs, and we're being asked to compute its weight in US customary units. So let's go ahead and figure out how to do that. I'm going to write SOL for solution here, okay? And in order to calculate weight, we need to remember that weight is equal to mass times acceleration due to gravity, okay? And so that mass we were given as 3.72 slugs, and we need to multiply that by g. Now, what is g? It's 9.81, right? Be careful, it's 9.81 meters per second squared. We're in US customary units, so we need to multiply this by 32.2 feet per second squared. And so when we crank this through, we get 119.8 pounds, okay? And if you remember, when you say slugs times feet per second squared, you'll get units of pounds. Now, this is reported to 4 sig figs. If we want to obey our 3 sig figs of slugs, which is obeying sig fig rules, then we can round this to basically 120 pounds, okay, or 120, with a decimal point afterwards if you want. But again, remember in our previous video, we said we can round intermediate answers to 4 sig figs and maybe final answers to 3 and be okay. All right, so about 120 pounds. There you go. What about example 2? All right, similar kind of example. We're being asked to compute the weight of the hanging box. So here you have this mass that's hanging maybe from a cable system, and you were given the mass as 18 kilograms, and we want the weight. So I'm going to write solution here, and I've got the same relationship that we just saw. Weight is mass times acceleration due to gravity. Here we've got 18 kilograms, but here is where we're going to use the 9.81 meters per second squared because we're dealing with SI units. And so this comes out to be about 176.6 newtons. But, I'm going to go ahead and round that maybe to 177 newtons. And like we said in the previous video, typically for, what we're dealing with, because it's these are macro quantities, we can round intermediate answers to 4 sig figs and finals to 3 sig figs, okay? Another thing that I want to point out here is each of these little points on this diagram represents a particle, okay? Now, we're not getting into particle analysis just yet, but just store that in your back pocket for later. All right, let's move on down. Let's do a third example here, okay? Here we are given 2 particles, A and B, that are accelerating along the same line of action, and they collide. So we have this little diagram they were given. We have a particle A and a particle B, and you see they're moving towards each other, and they eventually collide, okay? If the collision force is 1.5 newtons, what are the accelerations of each particle, okay? So under solution, the first thing I want to note is we're going to obey Newton's, which law? Third law, okay? What does Newton's third law say? Well, it says that whenever you have 2 objects that interact with each other, they're going to exert an equal magnitude force, but in opposite directions in a collinear fashion, okay? So look back at your Newton's laws as a refresher, all right? And so what that tells us is this collision force of 1.5 newtons is going to occur when these two particles hit each other, okay? So this collision force right here is going to cause a force in each direction, but in opposing senses relative to each one of these particles, okay? And so the way I can express this is I can say this force is equal to the mass of particle A, let's use capital A there for the subscript, times the acceleration of particle A. But that same force is also equal to the mass of particle B times the acceleration of particle B. All of this, both of these forces, they're both the 1.5 newtons, okay, because you have this collision occurring, right? And so in both of these cases, I can say 1.5 newtons equals the mass of A, which I know that's 3.5 kilograms, times acceleration of A. And then for the, relevant to particle B, I can say 1.5 newtons times 2.5 kilograms times the acceleration of particle B. And so in each of these equations, I can solve for those respective accelerations. And so just solving for each of these accelerations, I get 0.429 meters per second squared for the acceleration of particle A. And then for the acceleration of particle B, I got 0.6 meters per second squared. And so we could box those in as our two final answers. And again, this is just kind of an exercise of Newton's third law. So that concludes this short video where we just kind of reviewed some concepts of our introduction and background material for a statics course, which is really some concepts from Physics 1. If you found this helpful, please hit like and subscribe and keep watching through the playlist to enhance your knowledge of statics.